Today's problem was submitted by a viewer, and it says, when a polynomial in x is divided by x minus a, the remainder is r1. And when it is divided by x minus b, the remainder is r2. So that the remainder, when the polynomial is divided by x minus a times x minus b, is r1 minus r2x plus ar2 minus br1 over a minus b. Okay, I think it wants us to prove that this is the remainder when it's divided by this product. It doesn't actually say. Yeah, the wording of the question is, it's just a statement. There's no question, but I believe it's asking us to show that this is the remainder. Okay, so let's say p of x is our polynomial. And by definition of polynomial division and remainders and so on, I'll say that this is equal to q sub a of x minus a plus r1. And we also have that p of x is equal to q sub b of x minus b plus r2. So this is what it means if I take the polynomial x and divide by x minus a. The remainder is r1, and the quotient is qa. And when we divide by x minus b, the quotient is qb. So we need to show that px is equal to, I'll just call it q of x, times x minus a, x minus b, plus r3, where r3 is equal to r1 minus r2x plus ar2 minus br1 divided by a minus b. So this is what we want to show. Okay. So a few things I'm thinking here. You know, maybe we want to sort of put a common factor between these equations, like maybe multiply this one by x minus b and multiply that one by x minus a. In fact, I'm starting to see that might be a really good first step. So I'll take the first equation and multiply by x minus b. Okay, and I'm going to take the second equation and multiply by x minus a. Now, what I want to do is well, is this exactly the right thing to do? Like maybe I should take I mean, these things are not equal to each other, but what if I take a difference now? Or add, if I add or subtract these two equations, what will happen? Yeah, here's what's. I'm gonna subtract one equation from the other, because then I'll have a px times x and a px times x that cancel, and I'll be left with px times a scalar. So I'm taking the top equation and subtracting the bottom equation. Okay, and what I want to do now is manipulate this to end up with simply a px on the left-hand side, and you'll see that I have an x minus a times x minus b that sort of corresponds to the definition of what it means to divide by x minus a, x minus b. Okay, so we have px times a minus b is equal to everything on the right-hand side. Okay, and I'll divide by a minus b. So I now have px is equal to qax minus qbx divided by a minus b times x minus a, x minus b plus r1x minus b. Let's rearrange this to make it look like what we're trying to show. So this is an r1 minus r2x plus r2a minus r1b, all divided by a minus b. Okay, so what's written here is the definition of the remainder, the relationship between the remainder coefficient and so on. This says that when we divide p of x by x minus b times x minus a, the result is whatever that polynomial is with this as the remainder. And I believe this is the same expression that we were asked to show. Yeah, so that right there is the remainder that we were asked about. There it is. There it is written there. Okay. Yeah, this is a nice question. I suppose it's really just about testing your knowledge of what the definition of a remainder is after division, especially for when it comes to polynomials, but it's really no different than the definition of remainder for regular numbers. And then, writing down the definition of R1 and R2 like this, and then using those to manipulate the equations to turn into something that looks like this, and then it's just a question of figuring out what R3 is. Yeah, I don't think, again, the wording of what's sent here, there isn't actually a question or something we're asked to do, but I can't imagine that the question is intended to be anything other than showing that the remainder is this expression here. Yeah, if I have any more to say about this one, I'll write it down in the description. Thanks for watching, and thanks for the problem submission.